Now finally we're going to start working on our project. So the very first thing you have to do is you have to create your folder. So create a new folder and I'm going to call it ICO Token Sale. Make sure to write the name of the folder with lowercase, not uppercase. Otherwise it will throw an error. So make sure to open this particular folder in your VS Code. So come back here, go back to the open, come back to the desktop and select the folder. So here we are into this particular folder. Simply close this one, and now what we have to do is we have to get the starter file. I have already provided you the starter file. So come back here to the blockchain coder, and here you will find all the resources of all the project. So come here, go back to the resource code, click on that, and here you will find the entire source code of all the project we have built on our channel. So make sure to come and have a look. So click on this recent project, and here you can easily able to filter that. So this is the one we're going to work on it. So simply click on this get now, and here you will get the final code or you will get the starter file. So click on this starter file and it will take you to this GitHub repository, and from here you can able to get the starter file. So you can check all the folder and file structure. So simply copy the URL and come back to the VS codes. We are into the same folder. So open up your terminal, type git, so make it big screen, type git clone, paste the URL, and we have to give this dot, and it will create the entire starter file in the same folder. So give this dot and hit enter, and it's going to clone the entire repository in the same folder. So simply close this one, and now the very first thing we have to do is we have to remove this git folder, because when you will deploy you will generate your own git file or folders. So simply remove this one. And now let me give you a quick walkthrough of all the folder and file structure we have built for this particular application. So we have this component folder. Inside that you will find all the component we're going to create together. So we have all of this component. The structure is already designed. All we have to do is to write down the code. So we have this entire component. Now let's come back to the context. Inside the context we have these two files and the JSON file. So in the context, in the index, we're going to write down the entire logic, and here we have this JSON file of the contract. Come back to the contract, and we're going to create two contracts, one for the token and one for the token sale. So this is the token sale and token contract. Close this one. We have the pages. So we're going to have one page in our application, and this is the public. Inside that I will provide you the entire starter files of the CSS and all of the things. Okay, so you don't need to write the entire CSS. So make sure to have check all of this file, the CSS and the JavaScript, and some of the library we are using in our application for the animation. So close this one. This is the script, and that we're going to write the script for deploying our contract. Then we have the style. Inside the style folder we have this asset, in that we have all the assets, image and the CSS file. So don't need to worry about that. And we're going to write our custom classes, and we're going to import all the CSS file right here in the global file, which we're going to do it together. So that's the style folder. Here we have the test, here we have the utils. In this we're going to write our some helper function. Close this one. This is the get ignore, this is the hard config file, this is the Next.js, this is the package.json file, and here we have all of these packages. So make sure that you have to install the exact version. No matter when you are watching this video, you are watching after a year, 2 years or 5 years, you have to install the exact version. If you don't install the exact version, you're going to face some problem. So this is the one we have. So this is the dependency. So make sure to install this particular ether package, and this is the web3 model. You have to install the exact version, and this is the hard hat as a dev dependency. So this is the exact version you have to use, because when we'll deploy our contract, we're going to configure our deploy script according to this particular package. Because if you install the latest version, the script we're going to create is not going to work. So make sure to install the exact version. Again, I'm telling you, install the exact version. And this is the readme file. Here I have provided some important links so you can check. So all of the things you can check. So close this one, and now, so hope things are making sense, and now we can start working on our project. So the very first thing we have to do is let's run the application. So simply type clear, and let's start the application. Let's first install the entire packages. So what we can do, we'll simply type npm I and hit enter. It's going to install all the packages we have defined in our package.json file. This will take 1 or 2 minutes or 30 seconds depending on your internet speed. You can see in my case it's happened very quickly. So I'll clear the terminal, and in case you got any error while installing these packages, so in that context what you have to do is you have to install the packages one by one. So simply copy this package name and simply install that. So simply copy this entire package and simply copy that one and come back here in readme file and paste here and remove from here and install one by one. So simply copy that one, type npm I and paste. Simply come here, remove this and give this @ and hit enter. And that way you can easily able to install the package. So this is how you can install the package one by one, which again I'm not going to do it because I have no issues. So this looks fine. Now what we can do, we have installed the package. Now let's start the application. Simply type npm run dev and this will start our application on localhost 3000. So come back here in the browser, click on this and click on localhost, and here you can see our application is running absolutely fine and we have no issues. So far the entire setups, the entire application is running absolutely smooth. Now it's time to write the smart contract. So come back here in the contract, and first contract we're going to create for our token, and this time we are not using OpenZipLink library for creating our ERC20 token. We're going to write our own custom token contract because we have to add more function and we want to store the information about the user, those who will do the transaction, so we can fetch those information and display in our front end, or we can display in our dashboard. So simply click on this, the blockchain coder, the token we're going to create, and now let's start working on our token contract. So the very first thing we have to do is we have to import the license identifier. So this is the license identifier we want to use, MIT. Then we have to define the Solidity version. So I will go with above 8. Let's call our contract. So I'll call our contract the blockchain coder. You can give whatever name you want. This is the name of my token, so that's why I'm calling it. Now we have to take a string variable and we'll say public, the name of the token, so the blockchain coder, and we have to define the symbol. So I'll say TBC and I can say symbol, and I'll press Ctrl D. It will copy the line. This is the setup I have done in my VS Code, but in your case if you haven't done that, it's not going to work. So simply type it. So this will be the standard. These are the optional data I'm assigning just for my custom token, and I want to display the total supply, and this will be the owner of contract, and this will be the user ID. So let's do one thing, provide this comma, and now we have to change the standard to the blockchain coder 0v.01. So it's totally up to you. You can give any number. I just want to remove this because I want to take the supply as from the constructor. Let's remove this and remove this one. So these are the state variable we are using, and now let's take an array. So that's gonna be an address type, and that we're going to keep the information about those user who will take our token. So it's gonna be a public, and we'll say holder token. Then we'll have this event, and we'll have the transfer, and that we have to pass the address. We'll say indexed from, we have to take the address index to, and the value UNT 256 value. So this is what we're going to pass in our. Looks good. Now we can come here, we can take the second event, and that we have to create a approval event. So and that we have to pass the address we're going to approve for spending the token on behalf of us. So this is the spender address, and we have to define the amount, that how much amount they can spend on behalf of the user. So that looks good. These are the two events we have. Now we can simply come here, and we have to define the mapping. So this is the first mapping, which is the address type, and in that we're going to simply keep our struct. So we'll say token holder info public, and we'll say token holder infos. Okay, this is the first mapping we have, and now we have to create this struct. So let's create the struct. We'll say token holder info with a capital one, token holder info, and we're going to keep couple of data in that. So first data, we're going to take this UNT 256, the token ID, then we'll take the address, the from, the address to, and we'll keep the ID, the total token and this boolean value, which will keep the track whether he or she is a holder or not. So that's the struct we have. Now we can come here, we'll take a mapping, it will be an address type and gonna be the unt 256. We'll say public balance of, we'll take another mapping, it will be address type and it's going to return the nested mapping. In that we have to simply pass the address and we have to return the unt 256, and here we'll say public and it will call allowance because we are allowing other address. So that's why we have this nested mapping. One address is allowing other address to spend the token. That's why we have this nested mapping. Now we can come here, we'll take a constructor, and that we have to pass couple of data. So our constructor will take the unt, the initial supply, and first we have to set the owner of the contract. So whoever will deploy the contract is the owner. So the message.sender is the owner. Then we have to assign the balance to the message.sender because at the time of deployment the token will be created and we have to make it someone as an owner. So we have to assign the owner to the message.sender. So we have to pass the initial supply. So then we have to say total supply is equal to the initial supply. So that's our constructor. Looks good. And here I can see we have some issue. So it says convertible, and okay, here I have to do the changes. Come back here. So instead of this string I have to say address, and this will be also a unt variable. Obviously it's a number, and this one is also a unt variable. So make sure to do these changes. Now looks fine. So our constructor is ready. Now we can write the function. So let's create the helper function, and we have to create an increment function. So let's call it increment. It's gonna be a internal, and what it will do, it will simply increment our user id. So we'll say user id plus plus. So that's the function we have. Now we can come here, we'll take this function transfer. Inside that we have to take the address to and the amount. It can be a public return, and it's going to return a boolean value which is a success, whether it's true or false. Then we have to do a couple of checks. So we have to check for a condition. So we'll say balance of the message.sender. So those who try to transfer the fund, he has to have enough fund. So we'll say is equal to the value, equal to the value. So if he has the fund, then we have to go to the next, we have to increment the user id, and then we have to do the transfer. So we'll say balance of mess.sender, and we have to subtract from his account the value, and we have to simply update to the sender. So we'll say 2, and we have to simply update that value. And now we're going to simply call this token holder info function, and we have to simply update our struct data. So we'll take this token holder infos, we have to pass the 2, and then we have to simply update the entire information. So we'll say token holder info 2 equal to the 2, and we have the token info from, and that's called message.sender. Then we'll say token holder info 2 token holder equal to true. Then we have the token holder info to total token, and we have to say the value. Then we'll simply take this token holder info token id, and we have our user id. Once we update our struct, now we have to simply update our array. So we'll take this token holder, we have to simply push the user address, and we'll say this, okay, I'm getting this warning. So simply copy this one, and why I'm getting this warning. So what I will do, I'll simply come here. So that's okay, that's fine, no issues we have. Okay, here I made this spelling mistake, it's push, push. So that's fine. So once we're done with that, now we have to simply call our event. So we have to pass this message.sender to and the value, and that's wonderful. And at the end we have to return this true if it's went successful. So this is the transfer function we have. We are simply getting the data, updating and transferring. So that's the first two function we have. Now let's write this is called transfer function. Now we can come here and we have to create one more function called transfer from. We'll check this function transfer from, and in that we'll take the address from and the address to and the value. So these are the three information we're going to take it. It's going to be a public return, and it's going to return boolean value success, means true or false. Now we have to do a couple of check. So we'll take this value, it should be less or equal to the balance of the from the person who's sending. Then we have to do the second check, the value should be less or equal to the allowance, so the from, and we'll say message.sender. So that's how we are making this connection, because allowance is a nested mapping. After that we have to simply update the data. So we'll check this balance of, we have to subtract that balance from the form, and we have to simply update the balance to the same logic we are following here. Then we have to simply call this allowance, and we have to say from, we have to nest it to the caller user, and then we have to simply subtract the fund. Then we have to initialize the transfer event from to and value, and at the end we're going to simply return the true. So that's a very simple function we have here, not a big deal. Okay, so this function will allow us to send the token on behalf of someone else if he has the allowance. That looks good. Now we can come here, we can write the function called get token holder data. So we have to simply return the entire array. We'll say get token holder data, we have to get the address, and we'll say public view return, and we have to get all the data which we want to get from the user. So we have to define that. So we'll say unt, then we have to take the address, then we have to take the address, and the last one is the unt variable. These are the 4 data types we want to receive, and the boolean, whether he is a holder or not. And here we have to simply call our struct. So we'll return, we'll take our mapping in which we have all the data, we have to pass the address, and we have to simply call the data. So we'll say token id, and simply replicate this couple of times, 5 times, and we have to change this one. So this is going to be 2, this will be from, this will be the, let's say token total token, and the last one is the token holder. So things are looking good. Make sure to follow the exact order, because if your orders mismatch, it will throw an error. So order is very important in Solidity when you write your smart contract. So it looks pretty good. So these are the only function we have to write, and I'm getting some sort of warning here. So what I can see here is that somehow I provided this extra comma. Here I'm getting this error message because I have provided this extra comma. Remove this one and that will fix the issue. Looks good. Now we can come here, we'll write another function for getting the entire user array, token holder array. Get token holder public view, and we want to return the entire array. So address array, we'll say memory, and we can simply return the entire array. We'll say token holder token, and that looks good. So this is the entire function we have. That's pretty easy, and you can add more function. It's totally up to you that how you want to design your smart contract of your token and what information you want to keep it. But this looks pretty fine. So we are done with that. Now we can simply come here, and first we have to simply grab this license identifier and the version, paste here, and now we can start working on our token sale contract. So simply come here, we have to import our token contract. So it's coming from the same directory. This is the name of the file I have given, the blockchain coder. So this is the token contract, and now we have to call our token sale contract we have to build. So first we're going to take an address, call admin. Now we have to get the blockchain coder, and we'll say public, and we'll take this token contract. Then we'll take a unt variable, we'll say public. We have to take the token price, because at the time of deployment we have to tell our token sale contract that what is the price of the token. And here we're going to keep another variable, and in this we're going to keep the track that how many tokens are sold. Okay, we'll say token sold. So these are the state variable we have. Now we have this event, we'll say sell, and we'll take the address, of the buyer and the amount. Then we can come here, we'll take the constructor, and in that we have to simply update. So first what we're going to do is we have to take the address of our token contract and we have to pass into our token cell. So let's take this, the blockchain coder, and we'll say token contract, and that's what we have to update. And we have to also update the price, so it's a UNT and this is the token price. So these are the two information we have to pass into our token soul contract: the address of our token and the price. So we'll take this admin is going to be the message.sender, the one who will deploy the contract. Now we have to take this token contract and we have to simply update that to a token contract. Now we have to simply update the token price, which we are getting into our constructor. This is the token price. So we have updated our constructor, and that's the only thing we have to do. So the token contract and the price will come from the constructor, and we are simply updating into your token cell. So these are the few things you have to keep in mind. So these are the important things you have to keep in mind. Now we have to write the functions. So let's come here. We'll take a function called multiply, and this will allow us to calculate that how many tokens user is buying or how many token we have to transfer. So we'll take this s and y as a UNT variable, internal pew, and return, and it's going to return the UNT variable. Means it will do the calculation, it's going to return the value. So that's looks fine. And all we have to do is we have to do the multiplication. We have to say that y is equal to 0, and we'll say that z equal to x multiplied by y, and we have to divide it with y equal to x. So this will give us the actual price. Simple one. So this is the multiply function we have, and now we have to call this particular function buy token, and in this we're going to call this multiply function to multiply and find the value. So it's going to take couple of data. So it will take the UNT, the number of token the user try to buy it, public, payable, and the reason we have used payable keyword here because we have to do the transfer of funds. So we'll take this return and we have to check that message.sender is equal to the multiply, and we have to pass this number of token and we have to pass the token price. So these are the two information we have to price. So if user wants to buy 10 token and the price of one token is 1 ether, so it's going to simply multiply and it will give us 10 ether. So that's the very simple thing. But why I'm getting this particular error message? Okay, so let's have a look that why I'm getting this error. So this is the multiply, that's fair. This looks fine, no issues we have here. So these are the UNT variable, and here we have the pricing. And let's do the second check. The condition will say this, the token contract dot balance of, and we have to pass the address, this, and we have to simply, it has be greater or equal to the this number of tokens. Means here what we are doing, that we are checking the balance of the token cell contract, that it has enough token to make this transaction. If it's not, then we have to throw the error message. We have to cancel the transaction. So looks good. And here I can see the problem. It's not message.sender, it's message.value, because we are comparing with UNT, not with the address. So here what we are doing, that we are comparing with UNT variable with UNT variable, not address with UNT. So that's why we are getting that error message. Now looks fine. Now we can do the third check, in that we have to simply transfer the token. So we have to say message.sender, and we have to simply pass the number of token he wants to purchase. And what we have to do is, you have two options. What you can do is you can simply convert that entire token into ethers, the way term, with the help of JavaScript. But for being on the safer side, what I'm going to do is I'm going to convert that into way right on here in the contract. So all you have to do is you have to multiply with this one and add 18.0. So it will convert into 1 ether, because the price of our token is 1 ether, and that's what we are doing here. Make sure to add 18.0. So remove this one. You have two options. First, you can use Ether.js package in your front end to do the conversion but here I want to do it based on the smart contract, inside the smart contract without using the library, okay, for being more secure. Then we have to simply increment the number token sold to the number of token, and we have to call our event, and then we have to pass the message.sender and the amount number of tokens. So this is the buy function we have pretty much, and that's the only thing we have to do here in the buy token function. Close that one, and now we can simply come here and let's write one more function for end sell. And this is optional, but sometime what happened that you have to end your token sell, so you have to cancel the entire token sale and you have to withdraw the token into your address. So this is what the function does. So what it will do, that we're going to simply say public, and here we have to do a check. So we have to check for a condition. We'll say message.sender is equal to the admin, means the owner of the contract. After that we have to do the second check. So in this, what we'll say, we'll take the token contract and we have to transfer the fund to the admin. So we'll say the admin and we have to transfer the fund. So we will say token contract, and we'll call this balance of address. This means the contract, and we have to simply transfer that. So here I'm getting this error message. Did you mean token contract? Yes, I mean that. So what I can do is, let's okay, so a spelling mistake was there, so token contract. So I'm simply transferring the fund from this particular contract to my address. Now I can come down here, I'll say payable admin, call the transfer function, and we have to simply pass the address this, and we'll say balance, and that will transfer the fund and it will pay back to the admin. So things are looking pretty good, and that's the only thing we have to do here in the token sale contract. So looks pretty good. We have done all the function. We have the multiplication, buying, and the end sale. Okay, now come back here. So we have written these two contracts. Hope you guys have understood that what logic we have implemented and how we have written the contract and what logic we have functionalized. Close this one, and now we have to write the script for deploying our contract. So first we have to deploy, remove this API, the old API, remove this one and remove this one, because when we'll deploy our contract we're going to get an our API, and that's what we're going to simply drag and drop here in the context file. Close this one, come back here in the script, and let's write the script. So here we're going to use the library of Hardhat. So let's simply import that. So if you come back to the package.json file, make sure to use the exact version. Again, I'm telling you, if you use the latest version, it's not going to work, because latest version has a different configuration and old version has a different configuration. So if you're using this particular version, make sure to configure the way I'm doing right now. Come back here. Now we'll say cons hre, and we are getting this from Hardhat. So we'll say hard hat. Once we have that, now we have to build a helper function which will allow us to convert the ether into way, and that amount we have to pass into our contract. So we'll take this const, we'll say tokens, and that we have to pass the number of tokens, and here we'll use the ether package. We'll say return. So what I will do is simply remove this one. We'll take this ether only, and we'll say utils parse unit, and we have to simply pass the number and we have to convert that into a string. So that's our conversion function, and we'll define that it's an ether. So that's a very simple helper function we have, and now we have to write actual function for deploying our contract. So let's call it a seek function. We'll call it main. In that, first we're going to deploy our token contract, because our sale contract is dependent on token contract. So we'll have to take the initial value, that what is the supply of our token, and we're going to simply call the helper function, and we have to pass the number. You can create as many tokens as you want. I'm going with this number. Now we're going to take this variable called the blockchain coder, await, we'll call the ether package dot get contract factory, and in that we have to pass the name of the contract. So if you come back here, contract, this is the name I have given. Simply copy that one and come back here and paste here. Okay, looks good. Now come down, we have to simply deploy const, make it with a lowercase, the blockchain coder, and we'll say await, the blockchain coder, and in that we have to simply pass the supply. So we'll say initial supply, and then we have to simply call the await deployed. So we'll take this, the blockchain coder dot deployed, and this will deploy our contract, and we're going to simply console log out the address of our token. So we'll say the blockchain coder, and here we'll have this. So we'll say the blockchain coder dot address, and this will give us the address of the token contract. So this the blockchain coder has the entire object of our deployed contract, but from there we are simply accessing the address. Okay, so this is the first contract we are deploying, and now we have to do the second thing. We have to deploy our token sale contract. So first we have to do exactly the same thing. So we'll call the token price, because this time we have to pass the price of the token in our token sale and the address. So the price I want to set 1 ether. Let's take this token sale await. We have to call the ether dot get contract factory, and we have to pass the name of our token contract, which is the token sale, and we have to follow exactly the same thing what we have done above. Token sale await token sale dot deployed, and we have to pass we have to pass the address of the token and the token price. So we have the address here, the blockchain coder dot address, and we have the price, the token price, and these are the two things we are passing. So if you come back to the blockchain coder, not here, so come back here, the blockchain token sale contract, and if you look at the constructor, in that we are simply passing the address and the price in our constructor, and that's what we are doing exactly here. Now we have to simply call our deployed function on token sale and console log out our token address, and we have the address of our token sale. So token sale, and we'll get the address, save it, and now we have to simply call our functions. We'll call main. We have to catch an error if anything goes wrong, and in that first we have to simply console log out the error, and we have to stop the application once the contract is deployed. So we'll say process.exit code, which is a 1, and that's the entire script we have written for our deploying the contract. So helper function, then we are taking the initial supply of our token, and then we are simply deploying and consoling out the address. Then we have this token sale, we are passing the two data, token address and the price, and then we are simply calling the function. Come back here, close this one, and now we can simply deploy our contract. So open up your terminal, bring it up and split your terminal, and first thing we have to do is we have to run our local blockchain. So to run that, all we have to do is type npx hard node and hit enter. So it will start the blockchain locally, and it will give you 20 plus accounts. So each account will have 10,000 ether, fake ether, which you can use it. So you can see this is the private key of each one of these accounts. So it will give you 20 account, and each account will have a private key. So if you want to use any one of these account in your MetaMask, simply copy the private key and import in your MetaMask, and you can use that account. Now we can simply deploy our contract. So this is the exact command you have to write. We have to write this npx, let me bring this down. We have to type npx hard run network localhost and deploy script / deploy and hit enter. And here I'm getting some sort of error. So I know what is the problem we are having. So we are having in our helper function. So first we have to remove this artifact, remove this cache, and come back here in the script, click on that, and here we have the issue. So right now you can see that we have this ether utils. Okay, this is my bad. So remove this d, we don't need to have this d. It's called parse utils. So once you remove the d, it will not give you an error. So let's bring it back and come here, remove this artifact, stop the blockchain. Now we have to restart one more time, and now simply deploy, hit enter, and here we have compiled our contract and deployed successfully. And here you will have the address of the token contract and token sale contract. So you can simply copy, come back here in the context, in the constants, and here we can simply keep this to token addresses. So copy that one and paste here, and copy this and paste here. Now we have to simply copy the address, token address, and this is the token sale address, copy and paste here. So now we are done with that. Now what we can do is, now we have to import the ABIs. So come here. Here we have the artifact. Inside the artifact we have the ABI of the two contracts. So simply drag and drop in the context. So drag and drop in the context. So this is the token ABI, and here we have the token sale ABI. So simply drag and drop here. Looks fine. So we got the ABI, and now we have to simply import here in the context. So we'll say JSON file import the blockchain coder, and that's coming from the same directory /ABI. Then we have to import the token cell and coming here, and now we have to simply export. So first we have to export the token. So export const token address, and then we have to export the token ABI so we can receive in our different file. So ABI, so we have this token ABI. Now copy the address and paste here. So this is our token. Now we have to work on our token sale. We have to do exactly the same thing. Export const token sell address, and we have to get token sell ABI. So we'll say const token sell ABI, which we get from token sell .ABI, and copy the address and paste here. So that's the only thing we have to do here. So far things are looking pretty good. Close this one, and now you can come back. Looks good. Now you can come back to the utils, and let's create and write all the function for our help. And now what we can do is, before we proceed ahead and start working on our actual function, let's create all the helper function which allow us to communicate with our smart contract, connecting with the wallet, and getting the basic information about your contract. So all of those function we're going to create it right now in our utils file in index. So let's create that first. So first thing, we have to import the ether package and web3 package. So this is the ether package we have, and now we have to import the web3 model, and that's coming from the web3 model. So we have these two packages. Now we have to import the address and the ABI of the two contract, and that's coming from the contents. So let's import the token ABI, token address, token ABI. Then we have to get token sell ABI and token sell address. So these are the ABI and the addresses we are getting. Looks good. Now we can come here. We can export the check if wallet is connected. So this function will call every time the user will reload the browser, and it will try to find out whether the user is connected or not. It's going to be an async. We don't need to pass any argument. We'll take a try and catch block so we can find out if anything goes wrong, and we have to simply console log out the error. Now we have to call this. So we'll check for a certain condition. So first thing we have to do is we have to check whether the MetaMask is available or not in the user browser. And how we can do that? We can do it by the Ethereum object. So whenever a user will install any web3 wallet, it's inject the Ethereum object in the browser. So if there is a Ethereum object in the browser, means user have the wallet, but if it's not there, means user doesn't have the wallet. So we'll say window.ethereum object is not there. Then we have to simply return this message. We'll say install MetaMask. After that, if it's there, then we have to simply get the address, the very first address. First we'll get all the address. So we'll say window.ethereum request, and we have to call this particular method. In that we'll say method, and we have to say ETH accounts. So this will give us all the accounts which are there in the MetaMask. So once we have all the account, we have to get the very first account. So we'll say const first account. We'll say accounts, and we have to say index 1. That means 0, and that's what we have to simply return. Looks pretty good. So this is the check if wallet is connected function. So what we can do, simply do one thing, simply copy this and paste here, and this will say connect wallet. So on the base of click event, we are going to call this function. So here we're going to do a couple of changes. The only change we have to do in the method. So instead of ETH accounts, we have to call say request accounts, and the rest should be fine. And after that, what I'm going to do is I'm going to reload the browser. So come here, well, so window.location.reload, and here we have the current wallet function. Looks pretty good. So these are two function is fine. Now we have to communicate with the smart contract. So first we're going to communicate with the token contract. So we'll take this token contract and we'll say const fetch token contract. It's going to be an A. Inside that we have to pass the signer or provider. Take the callback function. So we'll take this ether package, we'll say contract, and in that we have to simply pass the address ABI and the signer. So first the token address, then the ABI, and then the signer or provider, means whoever is interacting with our contract. Make sure to provide the exact order. This order is very important. First address, then ABI, then the signer or provider. So we got our fetch contract. Now we can call our connecting token contract. It's going to be an async function, and in that we're going to use the web3 model to connect. So we'll take this try and catch block so we can find out if anything goes wrong, error. So first thing we have to call our web3 model function. So we'll say web3 and we'll say new web3, call it. Now we have to get the connection. So we'll say connection, and that's what we can get from web3 model dot connect function. Then we have to get the provider, and we have the, let's say, new ether dot providers dot web3 providers, and in that we have to simply pass the connection. So once we have the provider, and we can get the signer, so let's call it signer. We have the provider. On that we're going to call the function called get signer. So we'll get the signer. After that we have to get the contract. So we'll say contract, and we have already created this function fetch token contract. That function we have to simply call, and in that we have to pass the signer, because that's what our fetch contract function need, and it's going to return the entire contract. And now what we're going to simply return it. So in this way what will happen, that all we have to do is we have to simply call this function and pass the signer, and in that way we will have the address, it will have the entire contract which we can use. So this is the connecting token contract. Now let's create one more function which allows us to get the balance of the user. So we'll say get balance, simply change this to get balance, and all we have to do is we have to simply remove this. So remove this one, and we have to call the await signer dot get balance function, and it will run the balance of the user. So that's the only thing you have to do here. And now we have to do the same thing for the token sale contract, which we have done for the particular one. Simply copy this one, and that's what you have to paste, and here we have to do the changes. So let's change the name. So this is called token sale, and here we have to simply call that one, and here we have to change the address and the ABI. So this is the token sale address and token sale ABI, and that's the only thing we have to do. So our functions are looking fine. So we have written all the helper function which we can utilize in our application. So things are looking pretty fine, no issues so far. Close this one, come here. Now we are done with this util, and now we're going to start working on our context index file. So come here in the index file, and now we can start working on it. So simply type RFC, it will generate this boilerplate. Remove this one. Now we have to import couple of things from React. We need use state, use effect, you create context, and use context. That's what we are getting from React. Now we can come here, we'll import the ether package. We'll come here, we have to import the function we have created. So we'll say internal import. We have to come here in the utils, and we have to import each one of these function we have created. So simply copy that one, and that's what we have to call, and that's coming from the utils. So utils slash index. Now we have to get the current wallet, copy, and that's what we have to paste here. Come back here. Now we have to get the this is the function we have to get, connecting token contract. Paste here. Okay, bring it back, copy, and paste here. Now we have to get the get balance, copy, paste here, and now we have to get this one and paste here. So we are importing all our utils function we have created. Looks good. So far things are looking pretty fine, and now we can start working on our context. So we'll take this variable called const state context equal to create context. Then we'll export this our context provider. So we'll say export const state context provider. It will take the children, and we have to simply return it. So inside that we have to write all the variables, all the functions, and that's what we're going to simply export from this file. So what we can do is we can simply come here and we have to return. So we'll come here, we'll return that. So we already have our context. We'll say state context and we'll call this provider, and that's the general convention you have to follow in React context to export. So close this one and close this one, and here we can pass the value. So whatever we can define here, it's going to be an object. So whatever we want to export, all we have to do is to pass here and it will be available in our entire application. So inside this we have to pass the children, and that's the setup of our context. So let me show you and that's the entire setup of our context. So let me show you. Let's take a variable. We'll call it token ICO, and let's call it this token. Let's take a string. We'll say Token Sale DApp. So whatever function, whatever variable you will define here, you can simply export it. So simply copy that, and all you have to do is to paste here, and in that way it will be available in our entire application, in our entire component, and we can call it and we can have the value or variable. So that's the entire setup you have to do here in the context. Now what we have to do is we have to come back here in the pages, and we have to do a little bit configuration here. So first we have to get our context. We have to import, and that's coming from the index context / index. So we got it, and here we have to simply get our context provider. So what we have to do is first we have to export. So we'll say export const use state context equal to, and we'll call this use context, and in that we have to pass the state context, that what we have created above, and get this state context provider, copy this one, and that's what we have to call it here. So we have this our context provider, and now we're going to simply wrap our entire application with this context provider. So in that way the data will flow very easily. Simply copy and paste here. So in that way we'll have the entire data. So looks pretty fine. That's the entire setup we have to do. Close this one, come here. We have done all the setups, things are looking fine, and now we can simply use that variable we have created. So let's come back here in the index page. Let's do the internal import, and we have to call our context. So it's coming from /context index, and all we have to do is we have to call our use state context. So this is the context we have defined, and now we can simply get the data. So we'll say const, and we'll call our use context hook. So if we come back here, you can see this is the variable we have defined. Simply copy that one, paste here, and that's what we can simply pass. So if you want to display this data, all I can do is simply pass that variable here, and it will work fine. So things are looking pretty good. We have done all the setups. Now let's start the application. So simply type npm run dev, and you can see that our application is started on localhost 3000. No issue we have so far. If I reload the browser, and here I'm getting this error message. Okay, I have a duplicate this particular function. So what I can do is I can come back here in the context. I can bring this down, and you can see, okay, here is the duplicate. So remove this one, and that will fix the issue. Simply copy, save, and come back here, reload the browser, and again I'm having the same issue. It's coming from the utils function. Okay, so we have to do the changes in two places. So there is a duplicate name. So this is the context. Make sure to do the changes whatever we have done here. Now we can simply reload the browser, and you will find that we have this issue in this utils. So come here, go back to the utils, and here we have to change the name of our token sale contract. So this one is for the token contract and this one is for token sale. So let's change this to dash token sale and copy, and that's what we can simply call our context. Paste here. Okay, only the value name, copy and paste here. Looks good. So that's the only thing you have to do. You have fixed all the issue, close all the files, come back here, and still I'm getting some error here. Maybe I have done something wrong in exporting the file and importing the file, so that's why I'm getting this undefined, and I know where I'm getting this issue. So you can see here I'm getting this particular problem. So come back in the app.js file, and instead of constants, you can see, I hope you guys have noticed that you have to say index. If you do that index, that will fix the issue. So I was stuck for 10 minutes and finally I found this problem. So now what I will do, I'll simply keep everything as it is, make sure to change this one. Now we can come back here in the index page, and let me just bring this back, because when I was finding the error I just comment this portion, and now it will work fine. Save it. You can see I have not done any changes, everything is exactly the same. Save it, and now you can come back to the application, close this one, and here you can see this is how the data is flows in our application. So everything else, this thing is working absolutely fine. We have no issues in our application. So we have written the smart contract, we have built the setup of our context, and we are feeding the data from our context to our UI component. So that's also looking pretty good. So things are looking pretty fine, and now we're going to start working. So every single thing is working absolutely fine. We have no issues so far, and now we're going to start working on our functionality. We're going to create a couple of state variable and functions so we can utilize. So let's start working on it. So here we are in the index context. First thing, I'm going to create a couple of state variable. So let's comment this one, and I'll take a state variable called address. I'll take another one, and this will be our call balance, only balance, not get balance. So simply to back, this will be balance, remove this one, and it's a capital B. Let's take another state variable, and this will call our native token. Then we'll take another state variable called token holders. It's going to be an array. Then we'll take another state variable, and this will be the token sale. Then we'll take another state variable, and this will be our current holders. So these are the state variable we have. Now we have to write the very first function called fetch data, and this function will allow us to fetch the entire basic information from token sale contract and token contract. So we'll say const fetch initial data. It's going to be an async function. We have to take a try and catch block, because if anything goes wrong we have to catch that. We'll say error. So first thing we have to do is we have to get the user. So we'll say get user account. So we'll say const account, and we have already created the function. We'll call this check if wallet connected, and it will return the address of the user. Once we get the address, we have to simply get the balance of the user. So we'll say balance await. We already created this function. In that we have to simply call this, and we have to simply set the balance to our state variable. Make sure to convert it into ether. We'll say balance dot string, and this will convert the balance in ether. Now we have to set the address. So far things are good. What we are doing, we are simply calling our check if wallet can function. It will return the address of the user, and that address we are setting to the state variable. The same thing we are doing with the balance. We are getting the balance of the user and setting up in the state variable. Now we have to work on the contract. So we'll say token contract, and now we have to find out, now we have to get all the information about the token from the token contract so we can display in our front end. So we have to call the token contract. So we have to get the token contract. So we'll say await, and we already built the functionality. So we'll say, what is the name of the function I have created? It's not this one. Let's come back here. What is the name of the function? So we have this connecting token contract. Remove this one, and this is the one we have to call it. Copy and paste here and call the function. So this will give us the contract object, and now we can call it one by one. So we'll take a variable called let token balance, because there are certain function we want to restrict. If the user has the balance, then we have to call the function, otherwise it will throw an error. So we'll take this let variable, and what I will do in this, I'll say if account means user is connected, then we want to simply call this function. We'll say token balance await token contract, and I'm going to call this particular function balance of, and we'll pass the user address. Else we have to set the user balance to 0. Hope things are making sense what I'm doing here. If user is connected, then I only want to get the address and his balance in the contract, otherwise I don't want to make the check, otherwise it will throw an error message. So that's the first check we are doing. Now we have to call all the functions. So get all token data like name, symbol, all the things. So first we'll say token name, we'll say await, we have to call the token contract, and we have to call the name function. So this will give the name of the token. Simply replicate it couple of times. Now we have to get the symbol, we have to get the closest one, we have to get the token. It's a total supply. This will be our standard. This will be the holders, and the last one is the owner of contract, and we have to get the last one, and this will be the address of the contract. So here we have to simply change the function name. So this will be the symbol, this will be the total supply, and here we have the standard, and here we have the function name called user ID, and here we have the owner of contract, and here we have the address. And the reason why I'm able to make this call, because when you declare a variable using public keyword, it will automatically create a get function. Okay, I hope you guys have basic understanding of Solidity and how it's work. If you are totally beginner, so make sure to take the Solidity course, in that I have explained every single thing. So here we have the entire data. Now we can simply come here, we'll take a variable called native token, and we're going to store all of this data as an object. So let's take this token address to token address, then we'll take this token name to token name, then we'll take this token symbol to token symbol, then we'll take this to token owner of contract, then we'll token owner of contract, then we'll take this, let's say token standard to token standard, then we'll take this token total supply, and we have to convert it into ether. So we'll use this ether.utils format ether, and we have to pass the token supply, and we have to convert it to a string, and that's it. Then we'll take this token balance, make it capital B, and here we have to do the changes. It's not small b, capital B. Copy and paste here, and here we have to simply copy and paste here, and we have to simply pass the token balance, and that will fix the issue. So looks pretty good. And here we have to take the one more, this is the token holder, and we'll take this token holder to number. So this will be give us that how many token holders we have. Looks good. We have all of this information right up here. Everything is looking pretty good, and here I'm getting some sort of error. Okay, I have this equal, so simply remove this one, and that will fix the issue. No issues we have so far. Now once we have the entire data, all I have to do is simply update in our state variable, in the objects state variable, yeah, set native token, and we have to simply pass the data. In that way everything is updated and available in the state variable. So now what I will do is, let's call the function and let's see that what data we are getting, everything is working or not. So simply call the function and save it. Come back to the application, simply reload the browser. You can see it will automatically call our MetaMask. So we have to connect with that, do the inspect element, and here I'm getting some sort of error, and I know why I'm having this issue. You can see this is the error message I'm getting, that something's wrong with our address, the wallet address. something wrong. So things are looking pretty fine here. Let me have a look. Let me comment all of this and let me console log out the address, the entire contract. And here you can see we have all the contract, we have the address and all the function we have defined. So it looks pretty good. Now what I will do, I will simply console log out the address, that we have the address. Okay, the address is also working fine, we have no issues in that. So let's bring this back, call it, and still I'm getting this error. So maybe this is something related to the network. So if I come back to the MetaMask, and okay, here you can see that I have connected to Polygon, and because of that I was getting an error. So I have to switch back to the localhost, select that one and reload the browser, and you can see right now we are not having any issue. Now let's bring everything back. So let's bring this back, remove this console logs, let's bring this back, select all this and bring it back and save it, and simply console log out this native token. And still I'm getting this error message that token number is not a function. Okay, maybe I have done some sort of spelling mistake. Yes, I did. Okay, simply comment this one and you can see everything is working fine. So we have all the basic information about the contract, the supply and all, everything we are getting. So our function is working fine. So if I come back here and if I try to look at what is the issue with this token holder, so something's wrong in that. So let's console log out it and let's call this, and you can see we are getting this big number. So there is no problem in that. Let's call this toNumber function and we are getting this 0. Okay, that looks fine. Come copy and okay, here is the problem. I made n so a spelling mistake. So let's simply replace this and it will work fine. Bring it back and this time it will work fine. We have no issues. If you open that, you can see we have this 0 and looks pretty good. So we got our native token. Things are looking pretty good. We have no issues. You can see every single data we are getting in our front end. So we have all the information about native token. Now we will move on, and now we have to get the token holders data. So those who will hold our token. So we'll say const get token holders, and we'll say await. We have to call the contract, and on that we have already have a function in our smart contract, get token holder. We'll call it and we'll say set token holders, and we have to simply pass that. So it will be available in array. Now we have to say getting token holders data. So this one is for the user. So we'll say if account is available, means user is connected with our contract, then we'll call this get token holder data, and we'll say await token contract get token holder data, and all we have to do is to pass the address. Looks good. And that way we'll have the entire information about the user. Once we have the information, we have to simply update that. So we'll take a variable called current holder, and it will have the information about token ID, so that we can have a user token ID, and we can simply have an access by the index, because the data will come in the form of index, okay, array. So we have to access the data one by one. So we have the ID, then we have to get the address, and the address is available in the one, and replicate it and change this to this will be total token, and this will be token holder. Let's convert that. So simply ether.utils format ether, and we have to simply get this, paste here, and we have to convert it into a string. So this will be 3 called toString, and do the same thing with this. So what I will do, I'll simply come here, change this 3 to 3 and 4. Things looks fine, and now we can simply update this data to the state variable. So we already have a variable for the user. So what I can do is we'll take this set current holder, and we have to simply pass this current holder, so it will be available in our state variable. Simply select this, and we have to keep this inside the if block. So simply select cut and paste inside the if block, because we want to call this function only when the user is connected. So it looks pretty good. So this is the if block we have. Things are looking good, no issues we have here. Now what I can do is, things are looking pretty fine. So first we are getting all of this data for the native currency, then we are working on our user holder. Now we can come here, we can simply do one thing, we'll work on our token sell contract, and we have to get the information. So we'll call this const token sell contract, and we already have the function. We'll say token sell contract, it will give the contract object, and now we can simply grab few from here and paste here, and all we have to do is to change the name. It will be the token price, this will be the token sold, and this will be our token sell balance. And we have to change the contract, simply replace this one, and we have to change the function. So this will be the token price, and this will be the token sold, and this will be the balance of, and in that we have to pass the address of the token sell contract. So that's easy. We can come back here in context and get the token sell contract address, and that's what we have to pass. So that looks pretty good. Now we can take a call this set token sell. Let's create an object. Let's store all this information in an object. So we'll come here, we'll say const token sell token price eth.utils.format ether token price, and we have to convert it. Let's do the same thing for the token sold, and we'll say token sold to number, and this one is the token sell balance. We have to convert it, utils format ether token sell balance, and we have to convert it. So it looks pretty good, and that's what we have to pass here. Save it. Things look good. Now if you come and reload the page, here we are getting some sort of error message that is not defined. Okay, I done some spelling mistake maybe. So here we have the token holder data. If I come back here, okay, there is a problem. There is capital D and small d. Because of that I was getting an error. Simply copy that one and simply replace, copy this one and replace with this all, and that will fix the issue. If you come back, and here I'm getting again one problem. It's token sold is not a function, so maybe something's wrong I have done. So what I can do is I can come back into the contract token sell, and here we have, okay, here we have s token sold. So simply change that to, it's called tokens sold, and this will fix the issue. And here we have the issue in the balance of, I know why it's happening. So instead of calling the contract, we have to call the token contract. So here we have to change this one. So come here, get the token contract, and that what we have to simply pass here, and this will fix the issue. You can see all the error is gone and things are looking pretty fine. So now what we can do is, now we can simply console log out all the data which we are fetching. So things are looking pretty good to me, and what we can do is come here. Now we have to work on the buy token function. So let's take a variable called const buy token. It's gonna be an async. We have to pass the number of token, and we'll add the try and catch, and we have to catch an error if anything goes wrong, error. Then we'll call the contract. First we have to get the amount and we have to convert it. So we'll take this ether.utils.parse unit, and that we have to simply pass the number of token, and we'll have to say ether. Then we'll take a variable called contract await. We have to call the contract. So once we have the contract, and here we have to call the token sell contract, not the token contract, because token sell contract will allow us to send the token. Okay, so we'll say buying, we'll say await contract dot buy token, and here we have the function. In that we have to pass the number of token user wants to buy. So what we can do in that, we have to simply pass the number of token, and we have to pass the value, so the converted value. Looks good. You can see that we are passing this token without converting into ether, because we have already done that in our smart contract. So that's what we are doing. We had already done this conversion, that's why we are passing straight away. Come here, we'll say buying, and we have to call this await function. Once the transaction is completed, we have to simply console log out this buying, and we have to reload the browser. Dot reload, and that will fix the entire issue. Okay, so that's the buying function we have here. Hope so far things are making sense to all of you guys. Now we can work on our transfer token function, and this function only called by the owner of the contract, because first we have to transfer the token to the token sell contract. Then token sell contract can sell the token to the other user. So let's create the function. We'll say transfer native token, and I will go with the hardcode value, because ultimately this function can be called only by the owner of the token contract, not by anyone. So we'll wrap this in try and catch. If anything goes wrong, we'll come here, we'll say const token sell address. So this is the address where we have to transfer. This is the token sell contract address. Copy and paste here. Then we have to define the amount of token we want to transfer. So we'll say token amount. So I want to transfer 500. You can transfer any value you want. Then we'll take this token. We'll say token to string. Then we'll take this transfer amount. We say ether utils parse ether, and we have to say token. Looks good. Then we can say const contract. We'll say await, and we have to call the contract. So here we'll get the token contract. Once we have the token contract, we have to simply call the function. So we'll say await, we have the contract. On that we have to simply call the transfer function we have in the token contract, and we have to pass the address of the token sale and the amount, and this will work absolutely fine. Then we have to simply console log out the entire transaction, and I can say wait transaction. Then we can simply reload the window after the transaction get completed, and that's the only thing we have to do. So every single thing is working fine, you can see that. So only these three functions we have to create. So one function for buying, one function for transfer. Now what we can do, let's console log out all the data. So first we have to console log out the token sell, and we have to get the token holder. So replicate it, paste it token holder, and now we have to get this token native token. Copy and paste here. Save it. Looks pretty good. Copy, cut this one, and reload the browser. And here you can see we have all of this data. So this is the data coming from the token sell contract, and you can see the price, the token balance, and the address. This is the entire thing we have, and all of the information we are getting here. Things are looking pretty fine. I hope you guys can understand what we have done here. So we are getting all of this data fine here. Now what we can do is we have to transfer a couple of token to the token sell contract. So what we can do, call the function here, and this is the function we're going to receive in our index page. So receive the function, and we're going to have a button, and on that we're going to simply call this function. So we'll say button we'll say on click, call the function. We'll say transfer and save it. Come back here, we have the button, and now we can simply work on transfer the funds. So first thing we have to do is we have to clear the MetaMask history. That's the first thing, because whenever you do your first transaction, the transaction will fail, and whenever you change your account address, make sure to clear the history, otherwise the transaction will fail. So once you do that, reload the browser, and now what you have to do is come back here. So you can see that this is the account number 2 which I have imported from Hardhat account. That's why you can see that the account has this much balance, and I can able to do the transfer of the fund, because this is the account I have used for deploying the contract. So that's the thing you have to keep in mind. So if I open up this console, you can see, as I told you, that Hardhat will give you this 20+ account, and it will use the very first account by default for deployment of the contract. So this is the address Hardhat will use for deploying the contract. So you can see exact address I have, and this address has this much fund, and this is the private key. So if you really want to import the account, all you have to do is to get the private key, copy that one, and click here, import account and paste here and click on import. I have already done that, that's why you can see I'm getting this error message, but in your case it will happen. So whenever you do something like that, make sure to clear all the history. So let's clear the history tab and reload the browser, and that will fix the issue. Click on this transfer, and here we have the MetaMask. You can see we are transferring the token. Click on the confirm, and here the transaction went through, and you can see that this is the token contract data we are getting, and right now we have 500 token available in Token Sale contract, and user can purchase. Everything is looking absolutely fine. You can see here the balance got down, and it's available in our Token Sale contract. So things are looking pretty good. I hope you can appreciate that how powerful it is. So that looks pretty good to me. Now what I can do is, so this is fine. Now let's do one thing. Let's export all the function, all the variable we have created in this index file. So with the very first one I want to export is the current holder, the state variable we have defined. Then we have to export the token sale data. Then we have to export the token holders. Then I want to export the native token, and we have to export the balance, then the address. So all of this data we have created and updated in the state variable, and that's what we are exporting. We can also export this by, so we can attach in the front end, and looks good. So make sure to do all of the things, looks pretty fine. And now we can simply export this connect wallet and the set address as well, so we can easily able to update the data. Okay, looks good. Hope things are making sense. Close this one, come here and close this one, close this one. Things are looking good to you. And now you can simply transfer as many tokens as you want. So let's transfer 500 more. And if I transfer, and here the transfer went through, you can see we have 1000 token right now here. So things are looking pretty good, and we are almost done with all the functionality of our applications. And in the next video, we're going to start working on our front end and connect this functionality and display the data in our front end. So hope so far everything is clear to all of you guys. If you have stuck anywhere, make sure to rewatch the video. The starter files are given, all the assets is given. Make sure to download that and simply work on the project. With that, I'm ending this. In the next video, we'll start working on our front end part. We're going to attach all the functions and make our application live and deploy. Let's move to that. Have a wonderful day. Bye-bye.